Go ahead and get started this morning. Hope everybody can hear me. We're going to be recording the session, so if anybody misses it, they can log in and download the session later. So welcome everyone to webinar series session number 2. Excuse me again. We're going to talk about lubrication excellence this month. We're going to talk about all the failure modes this month around lubrication and in your lubrication programs. And then next month, we're going to work on all the things you can do to eliminate these failure modes. Again, this is a small part of an 8-hour training course that we offer on-site and at public courses, but very important as you'll see as we go through the training. So again, a little bit about our company. Certified RCM Facilitator. We have our own RCM processes, have 2 different versions which are available for purchase. And you can see all the other training programs we do. We have some asset criticality software, 2 different versions of that, very reasonably priced, because this is one of the things that companies have to do, and we'll talk about later on in one of the training sessions about how important asset criticality is and why you should do it. And then all the way down, we're going to spend some time on the last 2 items, the next 2 sessions here. We also build plug-and-play lube storage rooms, which the rooms delivered to your site with all the containers, filtration, electrical, and all you have to do is plug it in and start using it. And then we also build a lot of lube filtration carts, trailers, freestanding equipment. Basically, a lot of the stuff's custom based on what the customer needs at his facility. So you'll see some of those opportunities for some of that equipment as we go through the training today. Again, based on our training off the PF curve, this is Reliable Process Solutions version of the PF curve. And you can see our very top item over here on the left-hand side is lubrication excellence. And I always tell people you can do all these proactive things. We can do precision alignment. We can do precision balance. We can do precision installation and follow all the rules for installing new equipment or rebuild equipment. But the very first time a lubrication technician or a maintenance person puts a dirty lubricant in that piece of rotating equipment, that equipment's going to fail 3 to 8 times faster than it would have if we'd have put a perfectly clean lube in there that was perfectly dry. So this is going to be our concentration on this session today, is how important lubrication excellence is, why we need to develop these programs at our facilities, and we're going to show you some charts, and we have more charts available, that we can send you in some mini lube manuals that actually show the difference in these different equipment types if we get these particles out and we get the moisture out. So we all know the basics of lubrication. The function of lubrication is to provide that film between the moving parts. A lot of times when we look at brand new bearings, we look at brand new gears, to the naked eye, those surfaces look very smooth, they look very polished. But actually, in reality, if we look at them under a microscope, there's these very small 1 and 2 micron imperfections that you see in the illustration below. And it's this lube film thickness that keeps those components from ever touching. Once we lose the lube film thickness, which, excuse me, by the way, is only 5 microns across, that's all the film thickness we have between our moving parts. Once we lose that, and then our parts are going to rub together, we're going to have metal-to-metal contact, we're going to have component-to-component contact, which results in friction at high temperature, and our components are going to wear out at a very high rate. So lubricant functions, one of the functions, reduce friction, like we just talked about. And if we can reduce friction and keep and maintain that surface, we reduce wear. Another function of lubricants is to transfer temperature, like in hydraulic systems and gearboxes. The temperature at the work points is very much higher, and you need those surfaces of the unit, such as a hydraulic reservoir or a gearbox, to transfer those temperatures to the ambient conditions. There's lubricants made with corrosion and anti-rust inhibitors. They can reduce corrosion. There's specialty lubricants produced to reduce shock. Lubricants create a seal for contamination. One of the reasons in my training, I train people when they're greasing electric motors. Maybe you're not greasing an electric motor for 100% the reason of lubricating the bearing, but it keeps contamination out. And so my customers along the ocean, like down in the Caribbean, where they have pumps out by the seawater, we keep the motors greased continuously with automatic lubricators. It keeps salt water from corrosion from getting into the bearing, getting into the motor. And if we use the right lubricants, such as synthetic lubricants, we can actually reduce energy. There was a client, not a client, but there was a company in the Ohio back in 2001 that actually measured the energy consumed on every piece of equipment in their plant, excuse me again, for a period of 6 months. And at the end of 6 months, they changed out all the petroleum-based lubricants, they added synthetic lubricants, and they actually reduced their energy at their facility by 9.8%. So lubricants can reduce energy. But like I said in a couple slides ago, lubricant film thicknesses are very thin in a loaded application. Lubrication layers for oil and grease applications are around 5 microns. Now, 5 microns, as we'll see later, is the size of a red blood cell. So it's these thin layers that keep the components from rubbing together and keep the components from wearing out. If we look at this animation, so we have these two components sliding against each other. These could be animated as a bearing or a gear. But in theory, if we could maintain that lube film thickness, those components would never touch and never wear out. But what happens in reality with these failure modes of our lubricants, the lubricant becomes oxidized, it can't hold the weight anymore. We get moisture in there, which changes the consistency of the lubricant, or the lubricant actually changes to a different compound, and we have wear. Or we get particles in the lubricant between this 5 micron surface, such as dust particles, which may be 40 microns, and we actually start grinding those particles up and we wear our components. But in theory, with a perfect lube, a perfectly clean lube, this component would never wear out. It would last forever. So in the process of RCM, which I teach this course a lot, what RCM does, a process developed by the airline industry, what it does, it looks at how components actually fail or how they have failed in process. And once we understand how the failure modes, we can actually select predictive tasks, preventive tasks, and sometimes different components to eliminate those failures. So this is what RCM does. Basically, it looks at different failure modes and how we can identify those failures and eliminate them. I put this example here. I go into plants all the time and I'll ask a question, why did that motor sitting on the floor there fail? And some people make comments like it burned up or whatever the reason may be, it overheated. But some specific component in that motor actually failed. Lubricants are the same way. They don't automatically fail. Many times it's the things we do that cause them to fail. So an electric motor is another presentation a training presentation I do. I don't think it's on our list this year, but I talk about the 50 failure modes of electric motors. So with these different 10 or 12 components in this motor, they add up to 50 different failure modes. And if we understand what those failure modes are and why they happen, we can eliminate failure modes in an item such as an electric motor and have the motor last many life cycles longer. So we'll talk about the same things with lubricants. Well, let's look at this picture. Why would this motor here fail at a faster rate? Well, again, here the screen on the back of the fan guard's covered. It's not getting the correct air across the motor. And the failure modes for motor insulation is for every 20-degree rise F in the temperature of the motor windings, the insulation, it cuts the insulation life in half. So by keeping the back of this motor guard clean, we get more air across the motor, we cool the motor better, and we extend the life 2 to 3 times. Here's a motor here that failed in a process at one of my customers. Now, why did this motor fail? Well, we can see it had product buildup in the vanes. It wasn't letting air get across the motor. The motor eventually overheated, so I don't remember on this one whether the windings actually failed or the bearings failed, but this motor overheated and failed. Again, we let this happen. This is something that motor could have been cleaned weekly, and we might have extended that motor life 2 to 3 to 4 times. So if we understand the process of determining failure modes, we can develop strategies in our operations to predict and prevent and eliminate these failures. So let's look at some failure modes of lubrication. Why would lubricants cause our equipment to fail? Well, sometimes we don't think of lubricants as having failure modes, and sometimes we think if we buy a lubricant, it's in its brand new drum, it's coming, and somebody opens it from the customer that it's clean, but it's really not. Many lubricants that are in the drums from our customers actually have particles in them, they have moisture in them, which creates some of the failure modes, which we'll talk about. So we're going to talk about the 50 failure modes of lubricants, and then there's another 30 failure modes that I always call about your lubrication excellence program. Things we're not doing, we don't have a program developed. So we'll look at some of those toward the end of the presentation. So I classify lubricant failure modes in 5 different areas. I have temperature failure modes, I have moisture failure modes, We have foreign material and particles that can be in the lube, which can cause not only the lube to fail, but the equipment to fail. There may be viscosity failure modes that we can talk about that will cause not only lubricant or our equipment to fail. And then other contamination, things besides moisture, things besides foreign materials that can get in our lubricants and change the consistency of the lubricant or cause the lubricant to oxidize at a much earlier time. So let's look at some common temperature failure modes. We have overloading. If we overload our equipment, we can create high temperature and cause the lubricant to fail a lot faster. Overgreasing. Putting too much grease can cause a high temperature. If we overfill, I do a little training session in my 8-hour course about when you overfill like a Gould's pump. If you put the oil level all the way to the top of the sight glass, that sometimes will cause that unit to run 10 or 12 degrees hotter. We have to get the unit down below the halfway point and even lower if we can, if we got good control, because it lowers the temperature and causes a condition that the lube will last longer. Sometimes the location of our equipment, when our equipment's located in an area where there's no air movement around it, setting in a back corner, setting inside a building with lack of air movement, this can cause higher temperatures in our lubricant. If we have the wrong viscosity, if we have high viscosity, it can cause increase in temperature. Poor lubrication circulation. Sometimes I've seen systems that have lube filtration systems on there, circulating systems, and the filter's partially plugged. Or there's some line restriction, and we're creating higher temps. Improper cooling, or no lube cooling. Sometimes we have to add a cooler, or sometimes the cooler we have on there is dirty, and it's not getting good airflow, so if we don't have proper cooling, we're going to have high temperature. Sometimes with multi-speed components, like examples of wind generators, examples of large gearboxes where you might have an 1800 RPM input and an 11 RPM output. Well, sometimes those create high temperatures on the high-speed side, and sometimes that's caused by viscosity and other issues. If you look at wind generators, wind generators, the prop turns at about 11 RPM. The output of that one gearbox is 3,600 RPMs. So sometimes that's going to cause thermal conditions that we can't control without using the right lubes. And then you have thermal conditions, sunlight. I was at a plant in Texas showing this one on their pumps in their tank farm in the mornings before the sun come up. The pumps were about 118 degrees Fahrenheit, and the motors are around the same thing. But when the Texas sun was shining on those pieces of equipment in the afternoon, they were 160 degrees, which that extra temperature on the pump housing was causing the lubricant to fail like 3 times earlier. Sometimes the ambient atmosphere that we've got our equipment installed in. Sometimes we have things with process heat. I've got one of my customers that processes lime. They have some gearboxes under some big rotary kilns. Well, the temperature under there is, around 200 degrees, which creates problems with temperature on the gearbox. So they have to do other things with viscosity and other methods to keep that oil and extend the equipment life. So here's some basic facts. Lubricants basically have a life of 30 years if we could keep them at 70 degrees F or 21 C. But very few of our operations are they that cool. But for every 20-degree rise of lubricant or rise in the temperature of the lubricant, we cut the lubricant life in half. So if you have a gearbox, let's say in your plant running 170 degrees, you have to replace that lubricant every year because the oil is going to oxidize. So let's look at this chart. This is a chart that shows at 70 degrees your lubricant won't oxidize for 30 years. But as the temperature goes up here, 90 degrees, 110 degrees, 130 degrees, we can see what happens at 150 or 170 degrees F. Look what the life of the lubricant is. Now these charts are relatively accurate, but there's some other factors. If there's any moisture present, or as the moisture levels go up, these lives go down drastically. So if you have things that are running at high temperature, and also another key point here is the first one in red, these are factors on mineral-based or petroleum-based oils. If you have synthetics and different additives, we can extend the life, like in petroleum-based oils. If there was a way, and there will be a way in a couple of years, we could add the oxidation additive in there and keep that oxidation additive level up. The lubricant would last longer. But synthetics will run at a lot higher temperatures than what I have here, and they'll last 3 to 5 times longer. So if you have high temperature applications, it's a very good reason to switch your lubricants to synthetics. So with petroleum oils, there's a defined life where the lubricant will start oxidizing more rapidly. You know, if you use the example of your car engine's running about 200, 210 degrees Fahrenheit. That's why the lubricants, your petroleum-based lubricants in your vehicles last about 3 months. They follow that temperature curve. If we switch those to synthetics, we can get 2 to 3 times more life out of the lubricant even in your car. So monitor your lube temps, use these life charts, and change the oil when it's oxidized. So what are some things we can do with temperature? Well, reduce the temperature if there's some way to cool it with air or water. We can change the lubricant more often because once the lubricant becomes oxidized and it starts turning dark and the acid number comes up, it's not a very good lubricant anymore. So we have to change the lubricant out. Sample the lubricant. A lot of times visual signs of oxidation, the oil gets really dark. It works in most equipment. It doesn't work very well in diesel engines because the oil gets dark in a diesel engine very quickly. But then you have to run a test, a lab test on that oil to see when it's oxidized or when the acid number is going up. You know, improve your understanding of viscosity. We're going to talk about viscosity in a minute. But as temperature goes up, viscosity comes down. So we may have to change viscosity in our equipment, and that may help control temperature. Understand that your greases have specific viscosities. If you're putting a grease in a bearing that the viscosity is too high, you may run a higher temperature. Always remember synthetics are better for temperature failure modes in every application. You know, you'll get some people say, well, synthetics are only good in some applications. Synthetics are better in just nearly every application. We'll look at that more here at the end. But again, the key things, think about RCM, eliminate those temperature failure modes. You know, what is the first sign of temperature failure issues? Well, you have to monitor that temperature. Now our next failure mode, we're going to talk about moisture. You know, in just about every area I've been in the world, I've done this training in 31 different countries. Well, there's a lot of these areas have ambient conditions. We have humidity in the air. You know, if you take the Texas-Louisiana border here, if you take the Far East area, Malaysia, Singapore, those areas, very high humidities. Some areas have lots of rain. So we're getting moisture from just the ambient conditions. Washdown practices at food plants, pharmaceutical plants, when we CIP, you know, we're spraying things down, cleaning every night, lots of moisture issues from that. If you have operations that run hot and they shut down and start up during the day, every time you shut that piece of equipment down, you're going to pull in, when it cools down, you're going to pull in outside ambient air, which has moisture in it. You know, using the right seals. A lot of times seals I see in equipment, it's just a single-phase Chicago rawhide seal, which very seldom lasts 6 or 8 months. But sometimes we can put better seals, Labrador seals, that help keep some moisture out. You know, moisture conditions, as the moisture goes up, you're going to deplete your additives in your lubricants a lot faster. The way you store your lubricants. We're going to talk about storage methods later on in the presentation, but are you storing your lubricants in an area where they can get moisture? Improper vent breather devices. You know, I go to plants all the time. They're not using desk case breathers or some kind of a breather to keep the moisture from getting in when the equipment is actually breathing. Or maybe their storage drums, they don't have a breather on there. You know, the drum warms up during the day, cools off at night. You're going to pull moisture in. So I've got lack of or depleted desiccant breathers. I've been in many plants where the breather's been on there so long that it's turned dark or it's changed color and nobody's changed it. I was at a plant in Nebraska about 2 years ago. The breathers have been on there so long they had mold growing on the inside of the breather. So again, we have to change those breathers out to keep that moisture out. And a lot of equipment that should have breathers on them don't have them on there. Now, one of the things our company's doing here in the next 2 months, a lot of people don't use the breathers because they're very expensive. They're $50, $60 a piece. But we're going to start selling a breather. You only buy the breather one time, and then we're going to sell you the desiccant recharge pack, which will be about $2 or $3. But again, a lot of people don't use the breathers, and they stop using the breathers because they are high in cost. So we've got a solution for that coming up here. Start-stop operations where moisture comes in. The component heats up, we shut it off, cools down. I think we got that up here at the top. You know, a leaky cooling system. I found this at a number of plants. They have cooling coils in there, and either the cooling is too cool, where it's getting below the ambient temp, we're causing condensation, or the cooling system may be leaking. You know, a lot of your old gearboxes with dipsticks. You know, one of the practices we did at Cargill's, we removed dipsticks from all our gearboxes, and we replaced those dipsticks with sight glasses. Because a dipstick's just another place for particles and moisture to enter into your equipment. So a lot of things you can see in the moisture failure mode area. But moisture is present in some form in most areas around the world. We can control it. There's different things we'll look at here on the next presentation next month, but lots of ways to control moisture. But look here, as little as 1% moisture in your oil can reduce component life by 50%. And we'll look at some slides of some other studies, but moisture, very big failure mode of lubricants. If you look at this chart, let's just go to our box here that has 1,000 parts per million. And what this chart's showing is if we can reduce our moisture to 50, it's 6 times the life on our equipment components. So you can see moisture has a huge effect on the life of your equipment. Some different breather oils. We'll talk about these again next month, but using desiccant breathers to control the moisture going in. This unit here, you know, the air goes in the top of the unit on the left one, goes through a dust filter. The air passes through the desiccant, which absorbs the moisture, and then into your unit. The desiccant unit on the side right here, the moisture comes in through the side, goes through a filter up to the desiccant, then it goes around and down a tube. But both of them serve the same purpose. One turns from gold to black, or gold to purple to black. One turns from blue to red to white. But they serve the purpose of taking the moisture out of the air before it goes in your unit. One of the units got a better design. The one on the left, if it gets completely saturated, the moisture goes right into your unit. The desiccant unit, the moisture stays on the outside. So a much better design. But again, we'll talk about these more next month. Here's a unit. This is called it's basically an instrument air dryer, and you can bleed this dry air across the top of a hydraulic reservoir or across the top of a gearbox. And we can see the sample on the left here was 1,320 parts per million. We ran the dry air across the top of the hydraulic unit for 12 hours, and the moisture went down to 18 parts per million. So a nice, cheap, easy way of removing moisture from hydraulic or gearbox oils. But again, we have to have some actions for this moisture. You know, what about the moisture level that comes in from your new oil supplier? Many times we don't check that. So one of the things I always tell people is go to your oil supplier, who you're buying your drums from. Find out how they're storing your drums. Are they storing them inside a building out of the weather? Are they outside under a lean-to where they can get rain and moisture, where the sun's shining on them in the morning? They cool off in the afternoon. Check your supplier, because a lot of times when me and my son go do lubrication audits, we'll pull samples out of brand new oil drums, and we find out that there's moisture in the oil already, or a lot of times we find out there's particles in the oil. A lot of your vendors, even though you think they do, they don't filter the particles out down to these real low levels. So we have to watch that. Eliminate the moisture in your stored oils. Where are you storing your drums? Where are you storing your buckets? What kind of containers are you using to take the oil around to your plant? All these different components and all these different methods you have at your plant, you can get moisture in your oils before they even get to the equipment. And then what about the moisture in your equipment? You have equipment around your plant, it's heating up, cooling down, it doesn't have desiccant breathers on. There are lots of things we can do to keep the moisture levels down in your equipment. What about washdown practices in food plants and pharmaceutical plants? You know, numerous times at the plant I came from, I would go up there to be power washing at night, and you would see an operator power wash right on the shaft of a gearbox, right on the shaft of a motor, right on the housing, the junction box of an electric motor. You know, basically forcing water into the component. So there it was mostly training, and then we put some better seals on the equipment, used some Toshiba Tosh wash motors. We eliminated some of those failures, but again, it was a training issue. They didn't know. They were trying to get things clean. We also have to monitor our moisture levels. You know, one of the things we have to do is if we can visually see moisture, or we send a lab analysis in, if that moisture level goes up, sometimes we have to change the lubricant. There's better sealing methods, you know, Labra seals, desiccant breathers on critical equipment. You know, and I'm telling everybody you don't need desiccant breathers on all your equipment, but on critical equipment that's going to be a high dollar cost to replace, repair, we should have desiccant breathers on there. You know, desiccant breathers on your storage drums. You know, a lot of places I go, the desiccant breather on a storage drum will last over a year because the drum's not breathing that much. But again, it depends on where they're stored and how well you store them. Then these new devices, the dry air to remove moisture, using nitrogen to remove moisture. All things we'll cover in the next training session. But moisture, big issue for the life of your equipment. I want to touch on additives. You know, in all the lubricants you buy, there's additive packages in there. And these additives are in there to to keep the petroleum oils from oxidizing as fast. There's additives in there to reduce corrosion and rust. But these additives in there are in there to improve its lubrication properties. But again, these additives deplete over time. So without doing oil analysis, we don't know when the additive's gone. Sometimes me and my son find that the additives aren't even in there from the very beginning. But without you doing oil analysis, and we'll cover it next in the next session in more detail, we sometimes don't know if the additive package is there or it's gone. Lubricant additives. What kind of additives are we talking about? Well, if we look at this slide, and we see we've got our oil here in the yellow, we can have additives such as anti-foam. Anti-foam's in all your hydraulic oils, but it keeps the bubbles large so they go to the top and dissipate. Once the anti-foam's gone, the oil may get milky. There's dispersants in your engine oils. There's extreme pressure additives, all your EP oils and greases. These are additives that are in there to lay down an extra surface on our component under high load, high temperature conditions and keep the component from wearing. Detergents in your engine oils. Anti-wear, all your hydraulic AW oils. These are anti-wear additives. Very similar to EP additives. They lay down an extra coating of protection. They can be phosphorus, they can be zinc and hydraulic oils. Rust and corrosion inhibitors. They're in there. They lay down an extra surface on the component to keep moisture from getting to the component, to keep your internal components from rusting. And then all your lubricants have oxidation. All your petroleum-based lubricants have oxidation inhibitors, which keeps the oil from oxidizing or extending the life of the oil. So we must know, we must do some testing to find out what these additives are and how many of them are actually in there, not only in your new oils, but the oils that are in service. Because once the additive's gone, different things are going to happen to your oils and your equipment. Now, a lot of us, an example was a plant in Baltimore. And at this plant, when we got there, they had 47 different kinds of oils. And we were able to consolidate their oils down to 12 different oils. But some things you have to look at when you're consolidating lubricants, and there could be failure modes associated with this, but make sure the viscosities are the same, and make sure the viscosities are right for the process you're using. Sometimes we can consolidate by switching some minerals to synthetics, but again, we got to make sure that these two don't contaminate each other. But again, as long as it's a PAO synthetic and it's roughly the same viscosity, you can mix PAO synthetics and mineral oils. Make sure the additive packages, find out what the additive packages are in there. Sometimes there's additive packages that you won't be able to consolidate. One of the customers we had that had 22 different oils in the Washington, D.C. area, we were able to consolidate down to 10 different lube because we switched everything to synthetics. And synthetics cover a broader, wider range, and there's less additive package issues. What's the grade of the oil? You got grade 1, grade 2, grade 3 oils. What type are you using? Most commonly in plants are grade 2, but sometimes we have to watch that. We don't want to mix grade 1 and grade 2 oils together. Do you have food grade lubricants? These can't readily be mixed, and you can't use those to consolidate. And me and my son go to plants all the time where they're using the same filter system to filter antifreeze or coolants as they're using for their lube oils. Sometimes when you're consolidating, make sure you don't have any non-lube products in there. So we have to, whenever we're consolidating, we have to ask all the questions to make sure that our consolidation process is not going to ruin the lubes we have. Now here's some failure modes. Foreign materials and particles. Where do they come from? Well, a lot of plants are dirty atmospheres, or dirty ambient conditions. So we have particles in the air, steel mills, fertilizer plants, gypsum plants. There's roofing shingle plants. Lots of particles in the air, so the ambient conditions add particles to our lube. Contaminated new oil. Like I said, new oils aren't clean. There's particles in the new oil. What are they and how do we get them out? Our oil lube application practices. What are we using to put the lubes in our equipment? I've got pictures of, Downy bottles and Tide jugs and Drano bottles that people are using to add oil. How well were those cleaned? Water bottles is another common one I see. You have to get good, clean equipment to put your lube in. Then we get particles from the components that are wearing. As we have particles in our systems and we wear out our equipment, there's particles in the lubes from our equipment. What about greasing practices? You know, I go to the plants all the time and I see particles on top of the grease zerk. The guy comes by, wipes it off with a dirty rag. He puts his grease gun on there so particles go into the grease bearing. Improper filtration of our new lubes, or no filtration of our new lubes. Improper filtration of our process equipment. You know, sometimes your equipment in your plant builds up particles, and we have to put a filter card on there and clean those particles up. The lube sometimes is still good, but we're getting wear just from the particles in the lube. You know, I go to plants all the time where there's no filtration practices, where there has to be some filtration of your equipment. Combustion engines, I mean, lots of particles from combustion engines. Improper external vent, we talked about the desk case breathers, no vent breathers. Particles in new greases. Now, here's one thing I'll let you know, that all new greases, even from the major manufacturers, most of those greases have particles in there because our manufacturers are not making the greases and filtering the lubricants down to these real low micron levels before they make the grease. So there's very few name brand greases that are clean. Saw a couple companies that do have clean greases. Lubriplate, Lubrication Excellence. Petro Canada has some good practices for filtering the oils before they make the grease. There's a company in Oklahoma, Hydrotex, they're based in Dallas. They make some of the cleanest greases on the market. They filter down to real low levels before they make their grease. But these usually cost more, but your equipment will last longer. You know, poor lube storage methods, you know, where we're storing our drums and oils that come in. Poor lube equipment storage, you know, grease guns hanging on the back of golf carts and on the side of trucks, or containers with open lids in plants or not sealed lids. So you can see lots of practices here around foreign materials that we can improve to make our equipment last longer. If we look at this ball bearing here, it's a rotating ball bearing. If we say these two red particles on here could be particles in the oil, you know, as this bearing rotates and these particles come in contact with the bearing surface, this is going to cause wear. And remember, we said our lube film thickness in this rotating ball bearing is only 5 microns. You know, fine floor dust that you get off the top of a window seal or a picture frame, those are 40 micron particles. So how many 40 micron particles are in your facility, in your type of operation? And I'll ask questions about this rotating bearing here. How many bearings in your plant do you have that turn this slow? And probably not many. A lot of them are turning 900, 1800, 3600 RPMs. And then how many bearings in your facility only have 2 particles in them? Well, the answer is none. They have hundreds of thousands and millions of particles in there. They're turning 1800 revolutions a minute. And figure that out for a day, a week, or a year, how many times those particles come in contact with the loaded surface, and you'll see why your bearings wear out. But if we could eliminate all the particles in there, the bearings, in theory, could last. Here's a lube storage area, and I took this picture at a facility. But look at the lube storage area. It's in an area where they've got silica, they've got filter aid. There's filter aid and particles all over the lube drums and all over the lube equipment. Very bad lube practices. Here's one of the containers sitting down there. It was an oil container that they used to put oil in gearboxes. Look at the particles in the bottom. Look at the particles in the bottom of this container. The container on the outside is clean. But look at all these metal particles and dirt that was in the bottom of that container. And these things were getting dumped into the gearbox and equipment at this plant. So by changing these practices, we improve the life of the equipment. So we must understand that a loaded bearing, loaded gears, you know, that film thickness we talked about of 5 microns, it could be 3 microns if it's heavily loaded. It could go up to 10 microns if it's lightly loaded. But if you think about those dust particles in our plants that are 25, 40, and 60 microns in size, those are getting in our equipment. And with this thin film layer, our components actually have to grind the particles up. So what it's doing, it's grinding these particles up to where they're smaller than 5 microns. And when in doing that, it's wearing the equipment out. So we talked about this 5 micron thing, but look here, bacteria is around 3 microns. But 5 microns is the size of a red blood cell. So we're talking about very, very small particles. Talcum powder is around 10 microns. Fine floor dust, 40 to 50 microns. The human hair is 70 to 80 microns in diameter. So you can see the particles we're talking about, we can't even see a lot of times that are causing the wear on our equipment. And we'll talk about next month, how do we keep these particles out and how do we get them out. So any particle over size 5 microns is going to cause bearing wear. It's going to cause your equipment components to wear at a lot higher rate. So we're going to show a few slides on this, and if you guys are interested in a mini lube manual to further see what these life extensions can be, we can send you that. But let's look at this. If I'm hoping some of you guys are doing oil analysis, and you know what the oil analysis ISO code means. So when you get your oil analysis back, you'll see an ISO code in there. You should see an ISO code in there. If you don't, then it's not a very good oil analysis. But a common number here you might see is 21, 19, 15. So the first number in this series represents the number of particles. The 21 represents the number of particles that are larger than 4 microns. The 19 number represents the number of particles that are larger than 6 microns. And the third number, the 15, is the number of particles that are larger than 14 microns. Now, larger than 14 microns means that the particle could be 25, 50, or 100 microns in size. It doesn't get down to that detail unless you ask for more information in your lab analysis, but that's the high wear particles there, the ones in that 15 range. But here's what that 21 means. The 21 means that there's somewhere between 10 and 20,000 particles larger than 4 micron in a 1 milliliter sample. Not a very big sample. The 19 number means there's somewhere between 2,500 and 5,000 particles that are larger than 6 microns in a 1 milliliter sample. The 15 number means there's somewhere between 160 and 320 particles that are larger than 14 microns in that 1 milliliter. So you can see here there's lots of particles in a 1 milliliter sample. Most of your results in your plan, if you're not filtering already, are going to be up in this, could be as high as this number up here. Your big particle numbers could be up here in this number. And that's what I see in plants that aren't doing oil analysis, they're not doing filtration, so they're getting very high wear of their equipment. Or we could filter the particles down to where there's very few particles in the oil and make the equipment last 3 to 10 times longer. But look at these two pictures. This is a bearing on top of a bucket elevator, completely covered in dust around the grease, dust getting into the bearing. Here's some fan bearings down here. Same thing, we have to keep dust and particles away from the equipment, or find ways to keep them particles from getting into the components with better sealing and better methods. So again, and this is what I say when I go around plants. When I look at things like this, these are failure modes. And this is what you want to look at in your operation. We've seen the motors that were completely covered. That's a failure mode. So when we see our lubes dirty, we see grease bearings like this covered. Now there's a grease circ underneath that pile of dust that a maintenance person has to dig around to put grease in that bearing. Well, in many cases, we pump more grease particles into the bearing with the lube practice. Here's a gearbox life extension chart. So if we go back here and we look at this 22, 19, 17, which is similar to the one we just looked at, or this one, what we can see here, if we get down to a 16, 13, 11, that's about a 10 micron beta 1000 filter, but look what it does, 2.5 to 3 times the life. If we go down to 5 microns, 3.5 to 4 times the life just on a gearbox. In hydraulic units, the numbers are even higher. You can get 3 to 8 times more life out of a hydraulic unit by filtering it down to some of these lower ISO code ranges. So look at bearing life. Bearing life, it says 2.5 to 3 times when we clean up our oils just to these levels. And if we clean them up even farther, look at that, 3.5, 4 times. Now, I've got a couple of my customers that tell me that these charts are not even right. I've got a customer in Chicago that's put automatic lubers on with synthetic oil, and he's getting 6 years out of some bearings that he used to get 8 months out of. He hasn't changed the bearings for 6 years. So a huge difference in what they're doing there with these cleaner lubes. So for material, here it says help develop procedures to eliminate particles from all of our lubes. Filter your new lubes. They are not clean. Keep your lubes clean, before putting it in the equipment. So once you filter them in your new lubes, then we got to keep it clean all the way to the equipment. Keep your lube application equipment clean. One of the things we did at our plant, we bought oil-safe containers we got the guys using. As the oil-safe containers started looking dirty, we found out we could make them look brand new and clean them in a dishwasher. So we installed a dishwasher in our shop, and every Friday the guys would wipe as much oil out of the container as they could. They would put them in the dishwasher, come back in Monday morning, you had brand new oil-safe containers. Keep your lubes clean in your equipment. While the equipment's running, it's gaining particles. Sometimes we have to filter that equipment with filter carts to get the particles out of the equipment during the process. Buy grease products been produced with filtered oil or changed to synthetic. Synthetic lubes are cleaner because of the process used to make synthetic lubes. But there are companies that I mentioned that make perfectly clean or make better, cleaner greases. Now we have some viscosity failures. What's a viscosity failure? Well, as the viscosity goes up, the temperature can change. Your lube procedures can change the viscosity. If you're mixing storage and receiving, the way you store, we found a couple of our clients where they thought they had ISO 220 in their containers. They were pumping the oil in, and they had cross-contaminated. The oil was all the way down to ISO 150, and they were putting it in gearboxes that were supposed to get 220, so they'd contaminated it. Oxidation can cause the viscosity to change. Contamination, moisture, and chemicals cause the viscosity to change. What viscosity does, lack of proper additives or too much additives can change the viscosity, and we find a lot of lubes that have no additives ever added to the lube when they're supposed to be. So viscosity must be understood and be controlled. We have to have the right viscosity for the application. Now, sometimes a hydraulic manufacturer, a gearbox manufacturer, they'll recommend a viscosity, but they don't really know how you're going to use that piece of equipment in process, so you may have to change the viscosity, especially if it's in a hot area. Some rules for general rules. High viscosity oils are heavy oils. They're used on low speed, high load, high temperature applications. Your low viscosities are light oils. They're used on high speed, light loads and low temperature applications. But again, always use the correct viscosity for the application. And some things you need to understand about viscosity. And I'm hoping everybody understands what ISO 150 viscosity oil is. But remember, it's only ISO 150 at 104 degrees Fahrenheit or 40 degrees C. Look what happens to the viscosity as the temperature goes up. If the temperature goes to 140 or 60 degrees centigrade, it goes to 58. Look what it is at 215. It's 15. Now, whenever a component starts failing, what usually happens is the temperature goes up, whether it's a bearing or a gearbox. Well, as the temperature goes up, your viscosity goes down, which is going to increase the rate of failure. So how do we counter this? We may have to add a heavier oil. We may have to do something because viscosity is going down, and if it gets above 215, the viscosity can go all the way to 1. So we have to control that. I'm amazed at the number of plants I go to where it says here they don't understand that greases have different viscosities. I went into a plant a year ago and they said, "Oh, we've consolidated all our greases. I'm down to 1 grease." Well, you can't get down to 1 grease because you've got different speed applications that need different viscosities. You've got different load applications that need different viscosities. Electric motors need a special grease. Couplings need a special grease. So it's impossible at a manufacturer, especially at any large companies, to be down to less than 3 or 4 greases. You got contamination. Contamination from environmental conditions, leaky coils, lube practices can cause contamination. There's contamination that comes in your lube storage area. Your lube application equipment, not using the right equipment. Transporting the lube around the plant, we can get contamination. There's contamination that comes from your lube vendor. Lube equipment procedures. Storing non-lube chemicals in the lube area can cause some contamination. So we have to look at all these different ways we get contamination, and we have to figure out how do we control that contamination. Is there something getting in our lube that's not supposed to be? Is someone using a container that had antifreeze in it, and they're just wiping it out and then using it for oil or vice versa? That's going to cause contamination. It's going to cause your equipment to fail a lot earlier when those things happen. Again, all things that involve around training. So contamination is a little bit different than foreign material from moisture because contamination is things like coolant leaks, other chemicals, washdown cleaners. It could be leaky cooling coils in a plant from a glycol system. So again, we have to look at where the contamination is coming from. What can we do to keep it out? Precision lubrication? Probably not. Here's a lube storage area. We got used oils. We got new oils. We got mop buckets. We got all kinds of things stored in here. We've got basically a shower curtain for the isolation area here to keep particles and dust away. So not a good lube storage area. We designed some in shipping containers. Here's a 20-foot shipping container with containers, storage for grease guns and cabinets. It gives you a little bit of working room in there. So we build these in 20 and 40-foot shipping containers, all insulated, air-conditioned, heated, to store your lubes. Here's one here. It's got a wood floor in it. but the drums are set in here. The liquids are piped through or pumped through these pumps. They go through dual 10-micron beta 1000 filters and are stored in these containers with desiccant breathers. Excuse me. So now when the maintenance person comes in to get his lubricant, all he has to do is go get a perfectly clean lube out of these storage containers, air-conditioned, heated. Here's one here, one of our customers, it's got a steel floor, it's got spill control. They use steel tanks, but in steel tanks I don't recommend, but if they're stored in an ambient condition where they won't rust inside, they're fine. So here we've got an air conditioner, heater, steel floor, steel piping. Again, we basically build these for what the customer wants. There's one here that's got an insulated room with a wood floor. You know, if you don't like your employees picking up the drums, you know, we have basically a trolley system here. We can pick the drum up outside, move it into the room anywhere you want it, and it keeps the maintenance person from getting injured moving the big drums around. Here's a nice storage cabinet with their oil-safe containers. You can see here everything's stored in the cabinet, nice air-conditioned clean room. So again, the only way to control these contaminants at your plant is looking at it. Do this study. Find out where the contamination's coming from, where the particles coming from, and make sure you control those areas. Look at each of those failure modes. What do we see here is a failure mode. You know, this is like I said, this is one of a very expensive grease right here, very good grease. And look where the drums are stored. You know, the grease gun is covered with dust. The drums are covered with dust. There's a little bit of moisture in the background here. So lots of failure modes around storing this lubricant and around applying the lubricant. Now the operator is going to pick up that grease gun every 6 hours or 8 hours, and he's going to grease some high temperature bearings with it. Now look at the dust on the end of the grease gun. So these are failure modes we have to look for. So in contamination, check your new lubricants for contamination. You know, filter all your new oils. Store your lubricants in a controlled environment if you can. You know, use these oil-safe containers, but they're not good to use until you get your lubricants really clean. Otherwise, you're just taking dirty lubricants around, but they are much better than Tide and Downy jugs. You know, you can, when you order new equipment, get Labra seals put on your critical equipment to keep particles, dust, and moisture out. You know, use these online filters, you know, filter carts. If you look at our website, we have a lot of filter carts, filter trailers, where you can take a filter cart up to a hydraulic unit or a gearbox. We can hook on the drain line, filter the oil, put it right back in the unit. We can keep those moistures and particle levels way down the gearbox and extend that life 3 to 6 times. You know, get some training on this contamination elimination. You have to get your people trained that are doing the lubes. Synthetic lubricants. Again, I'd say they're better in every situation. They have higher thermal oxidation stability. They have lower pour point in cold weather. You know, lower volatility. They're less susceptible to catch on fire. They have less foaming characteristics because they don't mix with water. They don't go through hydrolysis like petroleum lubes do when there's moisture around. The lubricant lasts 3 to 5 times longer. Longer equipment life. You know, most of the things that we're using synthetic lubes in, the people are getting 3 to 8 times more life out of the components just switching to a synthetic lubricants. And if you have to dispose of your oils, you know, if lubricants last 3 to 5 times longer, your disposal cost is going to be down. Now, yeah, the cost for synthetic lubricants is higher, but you can see all the benefits here with your equipment lasting longer and some of these other benefits here. There's a big payback in using synthetics. Here's why synthetics work so well. If you look at the bottom here, petroleum-based oils. Now, these are not particles, but these are molecules that make up the oil. So petroleum-based oil, the particles are different sizes and they're different shapes. So you get some lubrication effect, but you can see with the molecules being different sizes and different shapes, you don't get perfect friction. Where synthetic oils are made with, they change a molecular structure where all the molecules are near the same size or almost the exact size, and so you get a better surface for your equipment to run on. You know, it takes less energy, you have less friction, and the lubricant reduces wear. So that's the easiest way to explain why synthetics are better than petroleum-based oils. You know, watch your operators. You know, your operators should be trained to know if there's oil loss, there's too much oil, if the oil changes, if it's foaming, if there's particles, if there's contamination. So again, there's operational failure modes we have to look at. So make sure that your operators understand these. Washdown practices is another one we just talked about. So look at the operational failure modes in your plant. So as you can see, just with lubricants, there's about 50 different failure modes. There's another 30 in your lubrication program. Not having a lube program or an incomplete program. You're not having documentation. Or have you got written procedures on how we order, receive, and store our lubricants? Are you using this RCM thought process about failure modes of lubricants and equipment? Improper sampling procedures. Sometimes we need to pull samples. We need to make sure we follow the procedures so we get a good sample. Not having an oil analysis program. Every industrial plant should be sending some samples off to be analyzed or buy your equipment to analyze them. No wear particle analysis program. What are the wear particles and where are they coming from? Improper oil drain procedures. So you can see a lot of program features here. Wrong additive package for the application. All things that we can cover later on with the training. Here's some more program failures. Not doing a lubrication audit. No lubrication excellence training for your people handling the lubes. No best practice storage rooms. No lube consolidation program. Get those lubes and greases consolidated down. Not looking at, a lot of people are doing oil analysis reports that are not really looking at the oil analysis report or understanding what they mean. Getting your people trained to do the lube work. Automatic lubers is something we'll cover in the training next month. Some of these are a huge benefit, especially in areas where you have high reactive work going on, and we may miss some of our lube practices. Using thin synthetics. So again, you can see a lot of program failures here that you have in your presentation material here that's going to help you with your program. So, look for some lubrication failure modes at your facility. Develop some lube routes. How are your lubes being checked? How's your equipment being checked? Written lube procedures. What lube goes in and how much? Can you consolidate your lubes, get them down to a smaller number of lubricants overall? This is something we can help you with. Even by internet, we can look at your lubes and give you some suggestion. Lube cost savings with better lubes. The better the lube and the more additives you have in there, sometimes the longer lube life. So there's some cost savings with spending more money on your lubricants rather than buying the cheapest ones. But again, what we're trying to do is get away from the right side of this curve where we have a lot of reactive. We want to move our resources over here where we're doing things in the proactive area. And one of the key ones that I tell everybody to do in their process is do this lubrication excellence step. Very important. Lots of information to be learned from this. That's why we have 2 sessions on it, and we'll cover some more of these things next month. So again, at this time, but we can have Justin open it up. If you have any questions I can answer now, you have my email address there if you want to email some questions. But again, I appreciate everybody attending session 2. I hope you learned some things you can take back and use at your facility. And again, we're going to cover some more things about this next month.